I understand that we have guests from a number of places, including the Mideast and Europe, as well as one or two from Asia and from South America. What I'll be doing is I'll try to make certain points about how some of the regulations and or economics here may impact our market, but you can certainly extrapolate to your own markets based on your own market conditions. So moving on here, again, we're going to be talking about a wide variety of vehicles, primarily in the area of fleet. First, let's just lay out what I think the compelling case here is here in the United States and in Canada, North America actually. So we've always had a clean technology, so we've got some great environmental benefits. But as more and more of the regulations come in to make all vehicles, regardless of their fuel source, become cleaner and fewer emissions, our relative emissions gain over other technologies starts to diminish because everyone has to meet those. So it's still something that we have as a great benefit, and it's a wonderful fuel source. But as you'll see, the technologies have been pushed to get cleaner and cleaner. Then it just gets down to what's the cost of those technologies to buy them and to operate them, and how does that create a differential between our fuel as well as what we typically are going up against, which is gasoline and diesel. Energy security is certainly important, but a real big driver right now is the economics. And that's what's really driving the greater use of NGVs here in the United States. We've primarily been focused on the fleets, and I understand in other parts of the world there's a great consumer market. I think we're going to see a burgeoning consumer market here as we see additional infrastructure being built. And one of the great things that's really driving this market is we have a growing selection of light, medium, and heavy-duty natural gas vehicles from the major manufacturers, or OEMs, as well as the specialty vehicle manufacturers, what you might refer to as the retrofit or conversion companies. And these vehicles are getting better and better, so our technology is really coming up to being delivering a par performance and reliability as to what it's compared to gasoline and diesel. Now, another point that's really changed our market lately is, of course, the fueling infrastructure. We've got a lot of different fueling infrastructure options out there now. We've got gas companies, we've got exploration and production companies that are going for gas and oil, and they see an interest in moving this. We see some leasing companies here in the United States like Penske and Ryder, of course, who have been building some stations and getting in there. We have some customers, but what's really interesting is we have the independent fuel retailers who are now joining what we have been driven by in our industry, which has been primarily our own natural gas retail organizations. And we see some great partnerships going on. We'll just talk about that briefly in a few moments. So we've got a lot of different people jumping in to provide fueling infrastructure. Now, one of the driving underlying cases here in the United States, and certainly I can say for North America, is that it's an abundant domestic fuel. And this is leading to a lot of different economic benefits. There's job creation, there's the trade balance benefits in terms of not spending as much on foreign oil, and of course not going after the foreign oil, particularly from foreign supplies that might be a little bit more volatile, certainly helps us with our energy security. So before we get into some of those other benefits, let's talk about some of the snapshot of the market metrics. Now, the current NGV inventory in the United States is listed at about 142,000 vehicles. And you can see here on the screen we've got a mix of light, medium, and heavy-duty vehicles. There's been a lot of growth lately in the heavy-duty sector. I'm just pointing out a couple of factoids here. In the transit bus market, we're averaging somewhere between 25 and 30+% of all the new orders for transit buses. In the refuse sector, where we've got some great economics, we've been getting around 50 to 55% of the orders for the last couple of years, and it looks like we'll continue to do that as more of the majors as well as the second-tier providers realize the benefits and need to compete with each other. We're also seeing some great movement in the ports and the regional haulers, the long haulers, as well as a number of heavy-duty applications with food and beverage and municipalities and others. In the light-duty sector, while we have a lot of light-duty vehicles that are still in the consumer sector, that are actually secondary cars, cars that were purchased after they were used by a fleet and then sold to the secondary market. Most of our growth in terms of sales on a yearly basis in light-duty vehicles tends to be in the commercial types of applications, such as pickup trucks and vans, whether they're used by utility companies, communications companies, cable companies. We see a real good push there, and there's a number of products that are available. Plus, those vehicles in commercial applications tend to use more fuel than just the average pickup truck, per se, or the average van, and that helps drive the economics. And that's a point that we'll get to in just a few moments. Now, in the medium-duty vehicle area, we have lots of great applications out there. We've got step vans, cab-over vehicles, we've got cutaways and shuttles, and we're seeing a fair amount of activity in that portion of the market. So this gives you a pretty good feel for where we are today with our inventory. Last but not least, the last couple of years, we've been tracking new natural gas vehicles that are being produced, whether it's by an OEM or whether it's by a retrofitter, putting on a system and making that vehicle now a natural gas vehicle or a new natural gas vehicle. We've seen a net gain of about 10,000 in 2012 and about another 12,000 in 2013. The numbers are very good. We have high numbers, but we also have some attrition of some of our older vehicles. That's why the net gain is less than the total number of new vehicles that were produced each year. But as you can see, the trend is upward, and it looks good, and it looks like it's going to continue that way for the next several years to come. Now, I want to mention something here. It's an important part of who we are here in the United States, and also there's similar environmental laws in Canada. The impact of the U.S. environmental laws really it's a big impact on what we have available to us as vehicles, and this might not be the same case in all countries. It's going to be based on your local policies and laws. But in the United States, the Environmental Protection Agency has jurisdiction over vehicle emissions. So the OEMs like Ford or GM or Chrysler or Freightliner, or the big engine manufacturers, we should say, they submit their vehicles or engines to our EPA for a specific engine family and model year, and then they get this approved, and it meets the requirements of today's laws. For our modifiers, they have to show that their retrofit systems meet the same emissions characteristics as well as diagnostic capabilities. They're issued what's called a certificate of conformity, which protects them from a federal law concerning tampering with the emissions control device. Now, this is part of our federal law. In March of 2011, EPA did amend its regulations to allow for what I will call a lesser burden of proof. There's still a burden of proof, but a lesser burden of proof for intermediate age as well as out of useful life vehicles. But all vehicles, and I really want to emphasize this because I know we have a lot of firms out there right now who are providing misinformation about this particular issue. All vehicles and all retrofit systems must still submit various levels of data and or technical documentation and be approved by the EPA, either as an approved listing or a certificate of conformity. So just be aware of that when you're out there and you're seeing some of the suppliers who I think accidentally in some cases feel that if a vehicle is a certain age that they don't have to comply with these rules anymore. There's always a burden of proof to make sure that your vehicle emissions meets at least some level of EPA review. Now, we have additional guidelines in the United States concerning the applications of those systems in terms of the safe installation, but that's not necessarily in the retrofitters markets. It's not done as a federal law. It's done as a guidance that the individual states, or perhaps in Canada, the provinces, really have the jurisdiction over. We really kind of move towards people staying with EPA and or here CARB certified systems to make sure that we're getting those full emissions benefits, as well as making sure that those vehicles are going to be properly installed by trained installers. Now, other countries' emissions requirements and their installation requirements and the related cost impacts will certainly vary. Now, here in the U.S., we have a growing list of natural gas vehicles from the OEMs as well as the SVMs. We've got all the major truck manufacturers you see on the left-hand side. There are a few that we don't have yet, but I'm hoping that they'll certainly join us, people like Fuso, Mitsubishi, Hino, but we've got a good, strong program there. We also have a number of vocational OEMs. If you look at here, you see Mack, Peterbilt, Crane, Carrier, Autocar, Truck. These are companies that are big in the refuse market. We've got the sweeper folks. And then the heavy-duty bus OEMs. These major manufacturers are building most of the buses that are being built for our transit agencies today. Now, we have a number of different systems out there that are repowers or retrofits for the heavy-duty sector. We'll talk about that in a moment. We, of course, have the light-duty OEMs. We've got Honda here in the U.S., not in Canada, but we do have it here in the U.S. We've got General Motors and Chrysler, and then Ford has a different approach to the market. They're producing gaseous fuel-prepped vehicles, which are then modified or retrofitted by what are called their qualified vehicle modifiers. And there's a number of those different firms that are out there. You see a list of all different kinds of firms that are in the retrofit business here on the right-hand side of your screen. So quickly, let's look at some of the vehicles that we have. In the light-duty vehicle area, we've got Honda with the Civic Natural Gas here in the United States, currently not available in Canada, but we're hoping they'll certainly move that vehicle availability up there. From GM, we have had the biofuel Silverado and Sierra for a couple of years now, and this year they expanded their options in terms of their cab configurations. We've had a dedicated van, which you can see right here in the middle of your screen. That's a cargo van, and this year they've added on the capability of having a passenger van. So I think that's a nice addition there. And then later this summer, we expect GM to roll out a bi-fuel GM Impala. So that'll be the first time in quite some time that we've had another sedan coming to the market. As you can see, the pickups and the vans are really more commercially oriented. Of course, we have in the lower right-hand side here, Ram 2500, which is a bi-fuel pickup truck from the folks at Ram Truck. Now, in the United States, again, because of the retrofit systems that we have out there, here's some of the other light-duty and medium-duty vehicles that we do have available through those retrofitters. Now, on the left-hand side of our screen here, you'll see a number of cars and SUVs, sport utility vehicles. There's not really a large number of them, and a lot of the certificates that we have available are for vehicles that are actually several years old. Where we really see the growth in this market is the vehicles that you see on the right-hand side here. Things like pickup trucks, vans, utility vans, cutaways. Here you see small cab over engine trucks like the Isuzu NPR. We've got the G4500 over here from GM. We have the Freightliner custom chassis people, as well as a number of shuttles. And then this year we added on a cutaway with from Thomas School Buses, which is helping us reach that smaller school bus market. When we move into heavy-duty powertrains, right now we are pretty much dominated by two engine families. We've got the 8.9-liter engine from Cummins Westport, which is a stoichiometric engine, meaning it's a spark-ignited stoichiometric combustion. It's cooled EGR and uses a three-way catalyst, very similar to that you might find on a car. The 11.9-liter, or what's called the ISX-12, that's also been out as of the third quarter of last year, and that's an exciting thing because it gets us into that 400 horsepower, a little higher foot-pound torque, which gives us more ability to handle some larger applications like 80,000 pounds pulling across our highways. The good news is that we have other development going on. I have several of them listed here. Volvo is expected to come to market with the 13-liter engine a little bit later this year. We will see late in 2014 for 2015 introduction the Cummins Westport 6.7, bringing us down to the low 200 horsepower and maybe, I believe, that upper 500s torque, maybe 600. And then Cummins has talked about bringing out a 15-liter spark-ignited engine in 2016, which will get us up into probably 450 to 475, maybe 1,700 foot-pounds of torque. They haven't defined that completely, but again, what you see here is the overall expansion of our ability to provide engine powertrains for the various kinds of applications that are out there. Well, let's take a look at where some of those powertrains are in this heavy-duty sector. Well, in the transit and school bus platforms, you can see all the major players here that have, most of them have the 8.9-liter. Some of the larger buses will have the 12-liter engine available, like the articulated buses. If you look in our vocational or specialty truck area, on the left-hand side here, you see the major players in the refuse market, most of whom have stuck with the 9-liter engine, although some of them are offering the 12 and some of the bigger models like roll-off models. And we also have a number of other vocational work trucks, and you see a nice selection of them here from Freightliner, Peterbilt, Kenworth, Mack, and let's see, I think I hit them all there. I didn't mention Volvo, but Volvo is in the next section, which is when you look at local as well as regional and line haul. Now here we're talking about tractor trailers that are typically moving freight across the country. We've got this both in the 8.9-liter, for example, on the left-hand side here you see a Freightliner M2. Freightliner also now makes the 12-liter engine available in their Cascadia model. In the center you see the Volvo VNM, but we also have the VNL available with the 12. Peterbilt over on the right-hand side here, international. And then down here you see some Kenworth T660 with the 12-liter. They have the T440 as well as the T470. Again, I don't have every truck that's available, but you get a sense now that what we're seeing is not only vocational and work trucks and buses and trash trucks, but we're seeing the kinds of trucks that are moving the freight across the continent. All right. So there's one other area that I think is important because as you're out there developing stations, one of the things we're going to look for is aggregating of load or enough throughput to create the economies of scale to help amortize the cost of capital and operations on a station. And one of the ways to do that is to look for more ways to move more fuel through your fleet. And one of those ways is through dual fuel technologies. Basically, what we have here is technology that will utilize the engine, the diesel engine that is existing in the legacy fleet. And as these trucks hit a certain age and or mileage limit, they become what is called outside useful life. That means that EPA will allow a system to be installed on those existing compression engine technologies, which will bring in natural gas and mix diesel and natural gas, where diesel is the pilot fuel and natural gas is then supplanting diesel fuel on a greater and greater basis as you go from idle on up to full throttle. The idea here is that you might have a truck that's 450,000 miles. It might have another 450,000 miles of life left on it. And what we can do is we can apply natural gas there and maybe get a distribution or substitution rate at the end of the day of perhaps 50% of the diesel fuel. This technology gives you an opportunity to bring natural gas and the benefits of natural gas to your existing legacy vehicles. And as that vehicle gets to the age at which it's now time to replace it or to sell it off to the next marketplace, you can then remove that natural gas technology and apply it to one of your other older trucks on your fleet. So you can amortize the cost of that technology even further. Now, it's still an approval process. You still have to have that EPA certificate here in the United States concerning the application of these technologies. And that still means that the engine data, the emissions performance information must be submitted to our Environmental Protection Agency for them to put this on what's called the approved documentation list. Again, beware of the errant information that's on numerous websites out there about systems that don't need EPA certification and or approval. That is not the case. Anytime you apply a different fuel or fueling strategy and change the combustion that will change the emissions, you're going to be under the purview of making sure that EPA knows that vehicle is staying within the guidelines. And that's kind of a rough way of putting it. It's much more specific than that in our Federal Register. You can look up the EPA laws right on websites. Now, currently, we have a lot of engines out there that have been approved for this kind of application from a number of suppliers that you see there at the bottom of your screen. Now, so what does this mean in terms of where we're going? That's what everyone wants to know. Well, there's a lot of independent forecasts out there, and I just have two of them here. There's firms, from Britain and other places that are putting out reports left and right. They're all taking a stab at it. Frost & Sullivan says that they think we might get to 8% of all the Class 6 through 8 sales by 2017, which is estimated to be a growth there, by the way, of about 370,000 trucks. That means 30,000 trucks going out on the road just in the Class 6 through 8 area running on natural gas. It doesn't even account for the things we can do with the Class 3 through 5. But even if you look at those numbers and say that's awfully optimistic, maybe we get half of that. 15,000 trucks would be some great numbers. It will help contribute to the economies of scale. It will mean more and more throughput for all of the various stations that are out there. And that means that we get better economy of scale, as well as a better confidence in the overall infrastructure for all fueling, right? Now, we have another study called the National Petroleum Council that went even further, and it looked at all the various world impacts of oil and demand and pricing and gas, and it put together this giant scenario. And what it came back with is, on an aggressive case where we have high oil and low natural gas prices, which we currently have and are expected to have for some time, they show that we could get as much as 50% of the light-duty market, a huge percentage of the 3 through 6 class trucks, as well as the really large trucks. I don't think we're going to get to that point by 2050. Maybe we will, but even if we get just a piece of that, you can see phenomenal growth. All right, so let's take another look at a different kind of snapshot of the market today. Let's look at natural gas consumption in vehicles. So we've tracked this here in the United States, and to the best that we can, and you can see that we've got good steady growth, but when we hit 2012 and 2013, we're really starting to see some great strong growth there. And I think 2014 and moving forward, that we might see numbers like 15 and 20% growth per year, because a lot of the new vehicles we're putting on the road are in the medium and heavy duty sector, which are vehicles that use just a lot more fuel per vehicle. And we expect that that growth rate is going to continue to accelerate as we get more and more successes and build more confidence in the sales and supply channels. The dealers get more familiar with it. They become more comfortable with selling those vehicles. They become more comfortable in explaining the benefits as well as the economics to their customers. And a lot of things are going to affect this. One is going to be the worldwide economic recovery and what happens with the demand for crude oil and the supplies of crude oil. It's going to be looking at that petroleum versus natural gas price differential on a BTU basis, which right now is very, very favorable to natural gas. It's going to depend on having lots of vehicle choices. And here in the United States, as well as in other countries that may have policies, if we get things like tax credits and or grants or other things, that can help accelerate the adoption of the technology. Now, again, this slide is talking about projections. What are people saying? Well, there's a lot of different projections out there, and if you look at the slide, you'll see that there's a lot of different numbers here. I mean, we're talking, one group says we might get up to 1.2 TCF of gas use. Another says we might make it to 5.1 TCF in half the time. None of these groups agree. None of these projections agree, but there is one thing they all do agree on. They all have a curve that looks a little bit like that chart here on the right-hand side, which is that we're going to see a quick accelerated growth in the marketplace. The two questions will be how soon does that occur? Is it going to be more to the left on this chart or more to the right? And what is the slope of that curve? Is it going to be strong, or is it going to be phenomenally strong like you see here in this particular chart? No one knows for sure, but we all know that it looks like it's upward trends and accelerated growth year after year. So let's look at one more metric of the marketplace, and that's the station count. Now in the United States, we have currently about 1,340 CNG stations, about another close to 90 LNG stations that are out there. And this is pretty good growth, but let's remember now, we have 138,000 fuel stations, 150,000 by some numbers. It's a large number. We've got a lot of fueling stations. We have a long ways to go. We certainly don't need to get to a fueling station at every single petroleum location. But I think for the United States, if we were to hit numbers that are up there around that high 4,000s to 5,000 stations, we would have a ubiquitous infrastructure that would certainly serve all the needs, not just of our commercial fleets, but also for consumers. And I think we can get there. We're already well on our way. One of the ways that we can tell that is we're seeing a phenomenal amount of capacity growth. In some cases, we replaced one small station with new equipment that's now made that station much more robust, more compression capacity, more storage, more dispensing capacity. On the list, it's still just one station. However, if we measure it from the standpoint of displacement of the compression capacity, we can see that our growth has been very, very strong. In 2013, we estimate that there's about 275 to 300 new stations here in the United States. We have seen some growth in Canada, of course, as well, along your major corridors. You've had some great successes there. Again, I can't speak to what's going on into the Mideast, South, or Asian or European markets, but there's certainly a good station growth, certainly I know in a number of these places as well. Now, currently about half of our stations are public access. Public access here just means that you're able as the public to buy fuel, to make a payment and purchase the fuel. It might be that you can do this with a credit card, or maybe you have a special card that you set up with the people who own the station so you can now purchase and swipe. The others would be behind the fence, private stations that are just for the fleet for their own use. When we look at public access, the concern today is to make sure that we upgrade all the experiences so that as a trucking firm or local small business or even a consumer, when they pull in, they want to see themselves at the station about the same amount of time. They want to get 4 to 5 gallons a minute if they're pumping gasoline. That's what they'd like for their natural gas car. If it's a truck, they're used to pumping maybe 10, 12, 14, 16 gallons of diesel fuel in a minute because they're filling 60, 70-gallon tanks. They want to see that same kind of robust, fast fill technology so that they can move along and get back on the road, because it's the time on the road, not the time spent fueling the vehicle, that's important to them. They have to be productive. So we're seeing a lot of effort towards building up that capacity within our own fueling infrastructure, sometimes beefing up existing stations and or making it a more robust station from the very beginning as we build it. Now, you hear a lot about compressed natural gas as well as liquefied natural gas. Both of them have a place in our market here in the U.S. and in Canada. The LNG infrastructure is being built right now. You hear about the America's Natural Gas Highway. It's great for those longer haul over-the-road trucking types of firms who are going long distances because of the density of LNG fuel. However, we can still get a lot of natural gas in compressed natural gas form on a lot of our trucks. If you think about it today, the frames that are being built, we can get about 130 usable gallons, give or take 10, 15 gallons. onto an existing 18-wheeler tractor trailer that is the kind of truck that's pulling the freight across our regional and long hauls. We find that a number of regional haul companies are certainly capable of doing this with either CNG or LNG, but when they start going the really longer distances, some people say over 450, pushing 500 miles, that is probably more advantageous for them to look at LNG. Again, that's going to depend upon where the source of the LNG is, the pricing of the LNG, the overall capacity or real estate on the truck for the CNG tanks, as well as the overall impact of the weight of LNG versus CNG tanks when you start getting to that amount of fuel capacity. There's no one right answer. Both LNG and CNG can both meet an awful lot of those needs in the heavy-duty sector. In the light and medium-duty sectors, we're certainly going to see that it's just CNG, and it's been that way for some time. All right, so let's talk a little bit about those stations. We said there's 1,425 of them out there. Well, we've had gas companies involved in this for a long time. We've had natural gas retailers. Clean Energy, the parent company here of IMW, is certainly one of the big players. We have a number of others who have gotten into the business of natural gas station development, ownership, and operations. We have some of the production companies, the people who are getting the gas out of the ground, seeing the value to help move that product downstream. Some of them are getting into this. We have leasing companies, as I mentioned earlier, customers. One dimension here is waste management. Waste management, I think, just opened up its 55th station where they're not only serving their own needs, but they're also serving the public. The picture in the upper right-hand side of your screen here is actually a place, it's branded as Clean and Green. This is actually a waste management facility where next to its time fill application for its trucks, it is selling fuel to the retail marketplace, to businesses and consumers under a brand called Clean and Green. Last but not least is this last bullet point here, which is traditional fuel retailers. It's really exciting when you see the traditional fuel retail market, the convenience stores, the gas stations, the truck stops. They're not really concerned or wedded to gasoline or petroleum. What they want to see is customers. Customers that come in and perhaps buy a cup of coffee or maybe a sandwich, something to eat, something for their truck or for their business. That is really the more profitable part of their business. So seeing customer counts increase and seeing loyalty and traffic from people who are coming to their station because they're now able to provide CNG as a fueling option, that's one of the things that's driven companies like Quick Trip and OnQ Express, which are convenience store chains. It's also been one of the major reasons behind people like Love's and Pilot Flying J, which IMW's parent company, Clean Energy, has a relationship with, to build stations at their existing truck stops. It's a marriage of what they do as a business and what they're very good at, which is locating the traffic flows, the land, putting together the entire operation, and now expanding their capability to provide any fuel that their customers might need. And in this case, that would either be LNG or CNG. So that's an exciting development. So going back to where we were in the beginning of this presentation, we talked a little bit about the idea of the driving factors. Emissions and air quality has certainly been a driver of change. In the United States, we've had various legislation over the years that's forced our government agencies to be looking at ways to reduce air pollution from factories and from other kinds of sources. One of the very important ones has been mobile sources. When it comes to our vehicles themselves, that's where EPA comes in, our Environmental Protection Agency, and they have driven technology improvements to all of our light, medium, and duty vehicles, heavy-duty vehicles, gasoline and or diesel powered, to meet stricter and stricter emissions requirements. So while we look at the impact of that, it's had an impact on the cost of the technologies to buy them, to operate them, to maintain them. And what we've seen is for diesel to, if you look on this chart here, for diesel to reduce its particulate matter as well as its NOx, down to this little box here in the lower left-hand corner, which happened as of 2010, they had to keep putting on more and more technologies that are complex, things like diesel particulate filters, selective catalytic reduction with urea water injection systems. All these various technologies come together to make those diesel engines down here in this little white box down in the left-hand corner. Now, natural gas has to fit in that same box, and we do. But we do it with technology that's not nearly as complicated. And what that means is that our cost differential between our diesel vehicles and our natural gas vehicles, that cost differential is starting to shrink, and then the maintenance of those complex technologies has also put a little extra increase to the cost of diesel technology maintenance. Now, that was the first phase. That was NOx and particulate matter. Now we see the phase-in of various greenhouse gas reduction and fuel efficiency requirements on heavy-duty vehicles, and this is further pushing the envelope for technology to improve itself to reduce its emissions. Now, we've met those emissions very simply. We've moved forward. We're getting better and better. The good news is that we reduce greenhouse gases between 15 and 30%, depending on which model by which agency is looking at the technology, and whether we're talking heavy duty or light duty. But we see definite benefits in greenhouse gas reductions, and that's an important part of a carbon reduction strategy for a lot of major corporations. Now, the downside to this is this. Our relative cleanliness compared to some of the fuels that we've been competing with over the years has really shrunk. Everyone has to be very clean. It's just now a matter of what's the cost of buying, owning, operating, and maintaining that cleanliness. All right, so what are the other drivers? Well, we all know that there's an abundance of natural gas. In this slide, we have 3 quick key points. The upper left-hand slide shows in the United States now, we're talking about the potential gas that's out there. Without having to read the entire slide, you can just see visually, we've had a phenomenal increase in the amount of gas that's available for us for the number of years coming forward. We now show that the shale gas, which has been a very big part of the U.S. gas abundance picture, it's really stretching our supplies to say that we're going to have gas for another 115, some people think as much as 200 years. Again, technology improvements and that ability to get to that gas at fairly low cost has really widened the gap that you see now in the lower left-hand corner, which is crude oil, which is the black line, and natural gas, which is the brown line. These 2 lines are based on an equivalent MBTU value, or British thermal units. As you can see, there's been a real decoupling of these 2 different numbers as of about 2 or 3 years ago, and that gap is what's really driving the cost differential at the pump. Right now, we currently are saving in the United States, depending on where you are, between $1.25 to $1.75 savings on compared to gasoline, and as much as $2 savings per gallon compared to diesel. Now, another very important point to remember here, because this has to do with how you think as a fleet moving forward. If you look at the lower right-hand chart, I don't necessarily agree with the numbers that are here, but conceptually, I think it makes a very good point. This is $4 gallon of diesel. All right, we're talking about a gallon of diesel fuel at $4. It shows that roughly 60% of that is crude oil. The rest of it's refining and marketing and all the other things to get that to your vehicle and to be pumped into your vehicle. I think the numbers now are actually on the later charts closer to 65 to pushing 70%. If you look at the right 3 bars on this chart, however, you'll see that natural gas is somewhere around, we'll say a rough number of 25% of the cost of CNG going into your vehicle. That means that the raw commodity of natural gas as a component that we stack together, there's compression cost, there's electricity, there's maintenance cost, there's the capital investment of equipment. When you look at that fully loaded cost per gallon, only 20 to 25, maybe as much as 30, but no more than that. That's what the raw gas cost is. And what that tells us is that we have much more ability to handle swings and price fluctuations in the raw commodity of gas, as opposed to diesel and gasoline, which are very sensitive to the fluctuations of the price of crude oil. That's an important thing when you're talking to fleet managers who are not just concerned about the cost of their fuel, but the predictability and volatility of their fuel pricing. So let's take that abundance now and translate it into savings at the pump. If we look at 1 million BTUs of fuel, if we divide that by 8, that's roughly the number of gasoline gallon equivalents of fuel or energy content in 1 million BTUs, approximately 1,000 cubic feet of gas. If we want to compare it to diesel, we say it's about 7.2 diesel gallons. Now, let's just make some assumptions here. On the bottom of this chart, you're going to see, I'm going to say that we're buying gas and getting it to our city gate at the utility for about $4.75. That number fluctuates a little bit. Right, that's 59 cents a gallon, 66 cents a gallon if we're talking about comparing it to diesel. But once we add the local gas company's delivery, the electric compression, the maintenance, the equipment, the capital investment in the compressors and the dispensers and the dryers and those other things, we're still coming up with something, we'll say roughly at $1.50 to $1.75, $1.80. okay? And $1.80 plus taxes is still going to put it significantly below where we are here at our current rates of pushing $4 for diesel and somewhere around $3.50 for gasoline. Now, where you are, if you're not in the U.S. or if you're in some of the other countries that I know are represented in our call today, you would be looking at your cost of gas as well as your cost of petrol being sold for your trucks, your cars. And again, it's that differential that helps pay back that premium that we typically pay for a natural gas vehicle, whether it's a truck, a car, whether it's from the factory, or whether it's one that we've retrofitted with a system after it's come out of the factory floor. That differential is going to vary on each and every vehicle and affect what the return on investment is that you as a fleet operator or fleet financial decision maker have to go through. So let's talk about what are some of those key attributes. Well, we like to see high fuel use. The higher the fuel use, the faster you pay back that differential in price. Now, we think that the best operations are those that are return to base operations like transit and refuse, or maybe somebody that's in the business of delivering food, beverage, dairy, products that are repeatable consumables that have to be replaced or replenished at the local store or restaurant or school or hospital on a regular basis. What you have here on this list is a wide variety of different kinds of applications. You see a long-haul truck up here using 18 to 25,000 gallons of fuel a year. At the other end of the situation, you have consumers. Consumers might use 400 to 500 gallons of fuel a year. In between there, you have a real mix of everything from transit buses all the way down to the local pickup at your local business, depending on what kind of business that is. As you can see, there are a lot of businesses that are return to base and or operating in a geographic area on a repetitive basis. Let's just say you're in the business of delivering soda or water or beer or other services. You're more likely than not going to be based in a metro area. You're going to go out and visit a number of locations in a day and come home. The next day you'll go to maybe some different locations, but they're still in your metro area. So it's a hub and spoke kind of operation that fits very, very well with the characteristics of CNG and having a central fueling location, whether it's on their own site or whether it's retail close to where they base their vehicles. Now, we have seen that the consumer market is certainly willing. Once the consumer sees that they've got fuel stations nearby, then they have the confidence to go out and buy and create a demand for a light-duty vehicle. The challenge there right now in the United States is that our light-duty vehicles still have a fairly significant premium, a premium that even if you're saving $1.50 to $2 a gallon, still requires about 7 years of fuel use, maybe 6.5, maybe 8, depending on how much you drive, to pay yourself back. And the reason for that is our cars are getting more and more efficient. We're getting 30 to 35 miles per gallon. So the more efficient our vehicles are, the less fuel they use, therefore the longer it takes us to pay them back. That's why we really focus very much on fleets, typically higher fuel use, as well as larger. The larger the vehicle, the more the fuel use to pay off that premium. Let's put this back into perspective on various kinds of fleet vehicles. I'm going to do a series of slides here that show you a real application with a vehicle, the cost, what the probable number of gallons a year that that vehicle might use, and how quickly it pays itself back, and then after paying itself back, how much money does it put back into its pocket as a fleet operator. So we're going to take a natural gas Civic sedan from Honda. Now, it's a very efficient car. Let's assume that this vehicle is getting a 31 miles per gallon city and highway. They're kind of a combination of the two. In this case, we have it as a medical lab service, literally a company that runs from the hospital out to the various doctor's offices and picking up blood and urine and other samples and returning test results. Now, they're going to use about maybe 1,000 gallons of fuel a year. That's more than twice the average consumer would use in that same vehicle. If they pay $6,500, they're going to have a simple payback of about 5 years, assuming they save $1.30 a gallon compared to gasoline. So without any kind of grant over the life of that vehicle, they might save $1,300 to $1,500 over a 6-year period. A small grant can really change the payback of that vehicle and give them even more life cycle savings. Now we're going to take the same pattern, but we're going to now start working into bigger vehicles using more fuel, and you'll see the pattern starts to emerge. Let's take a look at a passenger van or a limo, the kind that might pick you up and take you to an airport, or maybe it's constantly delivering people as part of a transit operation. Here we might have upwards of 90,000 miles a year, maybe 5 to 5,500 gasoline gallon equivalents a year. Well, if we spend $13,000 or $14,000 to make that vehicle a natural gas vehicle, without any kind of grant or incentive, we can get a payback of about 2 years, maybe even a little bit less. And over the life of that vehicle, or 6 years, we can save up to $30,000 just on that one van in our business. If I do, again, a grant to help reduce that and accelerate its adoption, I can see even better savings. Now we move on. Step van. This is a great application. These vehicles might use from 5,000 to 7,000 gallons of fuel in a local business, like delivering snack foods or bread or baked goods or maybe laundry services, right? You take that vehicle, and if you look at a savings of about maybe $1.50 a gasoline gallon compared to the gasoline costs, over a 10-year period, this vehicle can save $50,000. It has a payback of less than 4 years, typically around 3, and that kind of truck is usually kept in a fleet oftentimes 10 plus years, sometimes as many as 13 years. Again, a really good application. Let's move up to the next size, refuse. Why are we getting 53% of all the orders out there last year? Here's the reason why. A trash truck uses around 10,000 gallons of fuel, give or take 500 gallons a year. If it has a premium of $30,000 over the cost of a diesel truck for that same truck with the same capacities, even if there's no grants or incentives whatsoever, based on saving $1.50 per diesel gallon equivalent, this vehicle will pay itself back in around 2 years. And if you keep it for about 8 years, which is the typical life of a refuse truck in a contract for a municipality, you're talking about a savings of close to $100,000. This is the reason that companies like Waste Management, Republic Services, and so many of the next tier down of trash truck companies are so committed to buying natural gas trucks. Let's take one more and a little bit bigger. Let's take a grocery truck here. Now, I've taken a truck that's actually a real-life example from Pennsylvania, our state of Pennsylvania, where we have a company in Pittsburgh that's going about 6 miles per gallon, a little bit less than that, and they're driving about 100,000 miles a year using about 18,000 gallons of fuel. They spent $60,000 as a premium for this truck. But without any kind of grants or payback, their reimbursement of their investment is only 2.25 years. They keep that vehicle about 7 years or 700,000 miles, and over the life of that 7 years, they save about $125,000. It's an amazing kind of payback story, and this is the reason that we see more and more companies with these kinds of applications buying into this technology and really growing the marketplace. And of course, now we need to fuel these vehicles, right? So a lot of people say, well, we'll get these things as soon as there's more stations. How do we solve that chicken and egg conundrum, right? Well, I'm not going to build a station unless someone's got trucks that are going to come use my fuel. And someone says, well, I'm not going to buy trucks and cars unless someone builds me a station. So you've got a chicken and an egg. That's typically what we call the chicken and egg. Well, we say throw them both together and mix it all at one time. Create demand and create infrastructure fueling all at the same time. But here's what drives that market. You need to have the sales volume. The throughput of gas is absolutely critical to creating the economies of scale so that the people who are investing in that station, whether it's you as a business or whether it's you as a developer of stations, you're making an investment in this wonderful equipment, this compression equipment and this dispensers and all the other technology. You need to make sure that you're moving enough volume so that you can amortize your costs so that you can still provide a price point to that end-use consumer who's going to buy your fuel. They need to still save enough money for them to want to make that investment in the natural gas vehicle, the car, the sedan, the truck. So volume is really key. Now, how do we get volume? Well, if you're not lucky enough to find one firm that can give you all the volume you need, like 20 trash trucks, or even 15 trash trucks, or a bunch of transit agencies, maybe you find a bunch of businesses that are located near each other. Oftentimes in our municipal areas, our cities, we have zones where you have factories and warehouses. And in one small area, an industrial zone, you may have a number of businesses that part of their business is delivering their product, whether it's lumber, whether it's sheets, towels, whether it's food, beverage, they're delivering something every day. Those fleets individually might not generate the kind of the economies of scale or the throughput, but together all in that one area, we might find that they have an aggregated load that really drives great economics. So you want to try to figure out how to aggregate loads if one customer on their own doesn't drive that volume of business all by itself. And there's a lot of ways to do that. There's to work together. You can get several different what we call anchor fleets together to create enough volume. You might even create some public access so that in addition to those fleets themselves that are based there, this becomes a location that retail can sell the fuel for other people who travel through that region on a regular basis and know that you've created this island of fueling for them that they can get to. Or it might be a mix of all these things. But again, throughput, volume is what helps drive the economies that makes it a great idea to buy that IMW equipment and those dispensers and those dryers and make that investment so that everyone's making out on this. The end-use consumer, the developer of the station makes a profit, the people making the equipment. It all works together, but we have to have a certain amount of critical mass, and that's one of the things we work towards. So when you talk about your stations, we have off-site. If there's retail stations nearby, great, go use them. Get the best utilization as we possibly can. If not, you might want to do on-site location. Now, this might mean that you're working with your IMW representative to develop the right package that meets the needs. Maybe you develop a package for your own needs, but you also decide to make it a little bit bigger than your own needs so that you can sell fuel to others. So you provide what's called outside the fence public access. A great way for you to provide a service to your fellow businesses at the same time that you're improving your own economics for your own fleet. Now, you can go about this different ways. You can decide that you're going to own and operate your own station. You can decide to work with a firm like a Clean Energy, who's the parent company of our host today, and they'll build you a station. They'll take care of everything. That's their expertise. They'll own and operate it and maybe sign a contract with you for a price. Or you might even go somewhere in between. Perhaps you decide that you're going to buy equipment, put it in, and you're going to own it, but you'd like to pay somebody else who knows about this equipment to take care of it on a regular basis. So you pay them an operations and maintenance fee, maybe on a gallon basis, which is money that you're gladly taking out of your own pocket of profit, but you're putting it there because they're very good at that. They have the technicians, they've got the parts, they've got the know-how, and you stay to your core business. Therefore, you own an asset, but you pay someone else to take care of that asset to make sure it works for both of you. So the kinds of questions that will come up, and we're not going to try to answer this today. That's why you have the expertise of your IMW reps. They're going to ask you things like, how much fuel do I need each day? Not just in terms of the number of vehicles and on a daily basis, but very important, do I have peaks and valleys in my day? Do I have a daily flow in the morning that's really strong for an hour and a half? And then at the end of the day, does it go back up again when all of my vehicles come back home? Do I have a steady or do I have a roller coaster kind of demand profile? These kinds of things will help them understand whether or not the compression or the storage, what's the right balance. They'll also want to know about what other fueling is available in the area. If you don't have other fueling available, you might be designing something where you're using 2 and 3 compressors so that 2 of them can kind of match your load and the third is always a backup. So you've got that redundancy that makes sure that you are always up and running for when you're doing planned maintenance on one of the units that needs to be down. Now, you're going to look at real estate concerns. You're going to look at a lot of different things. You want to make sure you've got the room, the footprint necessary for your equipment. All these things your design consultant will work with you. And one of the most important things to look at, and you'll do this with your IMW reps, is talk to your local gas companies. Find out about the gas service, what pressure, what volume of gas, what's the condition of the gas, is there moisture in the gas? If so, how much moisture? You want to make sure that you're including all the proper peripheral equipment along with that compressor, such as dryers and separators, things to make sure that that is a good, strong, running, reliable operation. All right? Electric service is also a big piece of that, particularly when we start talking about compressors with these nice big motors. You got to make sure that you've got the 3-phase power capable and ready to go to handle that load. Again, a lot of different design considerations. That's why you work with your representative to understand, to define your needs so that they can understand the best approach to solving that question. All right, so let's just wrap up here with a couple of comments about crystal ball for what I think is going to happen in 2014. In terms of vehicles, I think we're going to continue to see even accelerated growth. I'm guesstimating about 25,000 new natural gas vehicles will hit the road here in the United States this year. I think we'll see moderate growth in the light-duty vehicle areas because the OEMs, people like Chrysler and GM and whatnot, they're getting better at selling those light-duty vehicles. Their dealerships are becoming more comfortable. They're getting a lot more requests for them, right? And I think the specialty vehicle manufacturers, the modifiers, the retrofitters, the kit people, whatever you want to call them, they're going to continue to offer those ones that make the most sense economically. And that's going to continue to be vans, pickup trucks, as well as cutaways that can be turned into various work vehicles. In the medium-duty sales area, I think we're going to do very well, but part of that will hedge on how well the OEMs like Freightliner Custom Chassis, Isuzu, Utilimaster, how well these companies work with the upfitters to make it a seamless operation for the customer. So the customer can say, I want a natural gas Isuzu NPR, and they get that vehicle delivered, and it's one sales operation, one spec operation, not dealing with 2 and 3 different companies. So that's an important part. I think we're going to see really good sales in the heavy-duty vehicle area. We're going to continue to see strong sales in that 8.9-liter engine in our transit, in our refuse, as well as some of our local haul. But I think we're going to see a real strong increase in the 12-liter engine, which just rolled out at the end of last year and is really going to get into full swing this year. I'm guesstimating 6,000 to 7,500 units this year. Now, that's not as optimistic as a lot of the hype that you see coming out of firms that like to tell everyone that we're going to do just wonderfully. But those are very solid numbers. The market is still being cautiously optimistic as they learn to adopt this technology, become familiar with it, and make it a part of their operations. But I think we're well on our way, and we've got great momentum. I think in terms of stations, we're going to probably see 250 to 300 new stations again in North America. It seems to be that this is about the number that the market is supporting, and as the market grows in vehicles, we'll get better utilizations of our existing stations as well as drive demand for new ones. Now, CNG will continue to get the lion's share of that. They have for the last several years. I think we'll continue to see LNG stations continue to be implemented, as well as the ones that we already have that will get used even more in terms of their full capacity. But they're really very well suited for the longer haul over-the-road operations. So again, those two work very, very well together. We may even see a number of locations where you have LNG and CNG, LCNG capability at one location. I think you'll hear more about that in your next webinar. So just a quick comment here about what we're doing here in the United States with regulatory issues and some legislative issues. One is that we're working on trying to reinstate some of the tax credits that were out there for infrastructure as well as for the fuel. Now, we hope to get these, but this is an election year, so it's a tough year for it to happen, but it might happen after the election this November. We're also trying to fix things like a current motor fuels excise tax penalty. We're paying a little bit too much, actually a lot too much, for our LNG in terms of taxes. We need to fix that so that it's equivalent to diesel gallons. We also have the weight issue. Trucks in the United States tend to be on our interstates at 80,000 pounds. Some of those businesses max out their total weight at 80,000 pounds. If we start putting on either LNG tanks and or CNG tank fueling systems that are adding more weight than the equivalent for diesel, what we've done there is we've now taken away some of the capacity for the load, the stuff that actually generates the revenue for that trucking firm. So we're trying to get a 2,000-pound weight limit exemption put on our heavy-duty vehicles. And this has already happened with some other technologies like auxiliary power units. They've given an exemption for some of that extra weight. We're currently trying to get that done at the federal level. We'd also like to see something called the excise tax on trucks. Trucks that are 26,000 pounds or more pay a special tax to the federal government of 12% tax. What we're hoping to do is to get that tax eliminated on the incremental cost of the natural gas truck. So if we're spending an extra $50,000 on a truck, we don't want to be paying an extra 12% on that $50,000. There's various approaches to this as to how we might get that done. Maybe they'll eliminate all the excise tax and shift it to maybe a fuel tax. But whatever it is, we need to get rid of that hurdle or that disincentive to moving more natural gas trucks out there. On the light-duty side, we're also working more with CAFE standards to get equal treatment of our natural gas vehicles. Now, some of these things we're not getting done at the federal level right now, but we're not stopping there. We're moving forward at the state level. My associate, Jeff Clark, here at NGV America, is working with a lot of the different state coalitions to take model legislation at the state level to get things like these weight exemption limits, to get tax credits, to get grants and other things that can help us move and incent that business at least in that one state at a time. There's hundreds of bills out there right now. Jeff has been tracking them, and as part of our member center on our website, We've got a great tool that he's put together where you can track legislation that's been proposed state by state. It's a great member benefit. Jeff's also taking the lead on something called the National Conference of Weights and Measures, where we're trying to officially adopt the diesel gallon equivalent standard. Throughout this presentation, I've mentioned diesel gallon equivalents. We know what it is in terms of energy content and how to measure it, but it doesn't exist officially in the handbooks that are used by those people who are responsible for making sure that all of our dispensing equipment is accurate and giving a fair value to the customer. We're trying to get a standard developed just like we have in gasoline gallon equivalents. So I've gone on now for about 55 minutes. I think it's time to wrap up there and maybe take some questions. I really do appreciate the opportunity that IMW has given to present this overview of the market. For those of you who are not in the U.S., you may see some similarities in your own countries in terms of policies or approaches that you may be able to take, but hopefully it's helped provide the bigger picture of how to go about the process. And with that, I'll turn it back over to you, Dave.
Thank you very, very much, Steve, and a special thanks to Steve. I understand that he's done 40 presentations in the last 6 weeks, so we deeply appreciate your time, and as always, the content is fantastic. Now, as we've hit exactly the hour, we'll quickly go over basic housekeeping here for those who have to sign off, and then we will continue overtime on some Q&A because we have received some excellent questions. So just quickly, a reminder that the next 2 webinars include innovations in natural gas transportation, or what some would call a virtual pipeline. That'll be hosted by Dave Van Laar, Engineering Manager, PEng at IMW Industries, and then May 22nd, Advanced LNG Fueling Station Technology by Michael Calderwood, PEng, who's General Manager of North Star LNG, who holds 75% market share in LNG stations in the United States. So without further ado, we will hop on to some questions here. So first question we've got, Steve, is from Ken. What is the process to comply with the Certificate of Conformity for intermediate age and out of useful life CNG conversions?
It's a great question, Ken. I think this is probably Ken from Penn CNG, if I remember correctly. Ken, the process is pretty clearly defined at EPA. For intermediate useful life and outside useful life, they have different burdens of data and proof, and they give you a little bit more leeway the older the vehicle is. But in general, you are still required, not you, the people whose equipment that you may represent, or if you're doing this yourself, they're going to be looking at things like how the application of equipment fits one to a specific engine family or series of families within a certain displacement size. They're going to apply certain rules about making sure that that technology still communicates with the onboard diagnostic systems to make sure that it's not just clean when it's put on, but that it remains clean over the life of the vehicle. And that onboard diagnostics capability is what turns on that check engine light or provides information back to the technician so that down the road they can fix that vehicle. And there will be some technical documentation of this. It's not just a matter of filling in some paperwork and sending in a fee and saying, I've got a technology, I want to apply it to anything I want to. It's literally a situation where it's going to be still specific to engines and engine families, and it will be supported by at least some level of documentation about how the technology works, as well as some information that's been collected in real-life data collection to support your request to show that your technology will work with that. For more information on it, though, I suggest that you go to the EPA websites where they define this process, and depending on if you're light or heavy duty, you'll be working with 2 different groups. One in Ann Arbor, Michigan. The other is based out of Washington, D.C.
Great. Thanks very much. We've got a question here from Dale. What issues or challenges are you seeing with dual fuel systems for diesel fleet trucks?
Well, I think the biggest challenge has just been the inertia in the marketplace. In general, what we see, there's 2 different approaches generally to this technology, and I would suggest that if Gail would like to go further, maybe contact American Power or Clean Air Power or FIDA or some of the other people who are involved in this technology, NGV, Matory, I don't want to leave anybody out, but what they're doing is they're typically starting an engine on diesel, number 1. 2 is that the engine will operate thinking that it's a diesel engine. Typically, the controller is still providing information or inputs to the various fuel systems and combustion to say, I'm a diesel engine. What's going on there is that there's usually a secondary technology that's taking that signal, and as there's a call for more power, it's controlling the amount of diesel fuel being put into the cylinder and the amount of natural gas that's being injected either in through the overall air intake system, that would be considered more of a fumigation system, or in one of the companies, they're actually doing it through injector technology that's bringing in the diesel and the natural gas through an injector up there at the what we'll call the valves on the engines. So what we see typically is an engine that will start on diesel, it'll idle at diesel. As you call for more power, what it'll do, it'll start to displace the amount of diesel and replace it with the same number of BTUs so that the engine is still seeing the amount of hydrocarbons that it wants. And the diesel fuel is still going to be the combustion starter. There's no spark in this. What you'll end up getting out of this is a displacement that could be as high as 60%, maybe even a little higher, 65% if you're running down the road at 60 miles an hour. But it might be that you're only getting 15 or 20% displacement if you're tooling around the city and you're primarily in lower RPM loads. So that at the end of the day, that you may end up getting about a 50% displacement of diesel and natural gas. The challenge there are two. One is the truck already exists. So we're talking about adding fuel to a real estate frame that's already been taken up with batteries and all these other things. We're seeing a lot of innovative approaches to this, which is, one, if we still have that diesel capability, we don't need to put on as much natural gas. So perhaps we put on a single 42-gallon tank of natural gas on the side, and the other side still has a diesel tank. Now what we've got is a vehicle that's got enough natural gas, plenty of diesel, to provide the engine what it needs for that day. Sometimes you have trucks that have got two 50-gallon diesel tanks, but that lasts them 3 days. You can remove one diesel tank, put the CNG there. Some people have tried putting it above the cab behind a cowl, that is the protective cowl. But what they're doing here is bringing about a $25,000 to $30,000 solution to a truck, and if you're running 20,000 gallons a year, displacing 10,000 gallons, you're saving $2 a gallon. That means that you're going to have a payback somewhere between 1 and 2 years, typically about anywhere from 12 to 18 months. And that's really the economic message we need to keep getting out there about this capability for legacy fleets.
Okay, thank you very much. We have a question here that I promise is not a plant, but Chris has asked, how do I compare one compressor with another? What are the key performance and cost metrics?
Well, actually, the IMW team that's on the line here is really going to have better expertise on this than anybody. But obviously, there's a lot of different compressor manufacturers. They make various sizes and displacements of compression technology. I'll answer this in a broad way. One is you're going to have to look at the application that you have. Are you in a situation where you're going to be running 8, 10, 12 hours a day, or are you going to be in an operation where you're possibly running 21 hours a day? And look at how much you are base loading that compressor. Like any kind of engine or compression technology, it's good to have a good solid base load. And the more you have fluctuations, that's why you'll see oftentimes solutions presented where you may have multiple compressor technologies so you can match the load better and remain in a good sweet spot for the particular compressor. Not just the compressor, but the motor or the engine drive that's driving that compressor. There's efficiencies of scale, and you really want to make sure that you've got a compressor that's properly sized to be a good fit for your application. There's not one rule to that for any. The other is you're going to be dealing with the various pros and cons of how well you're set up to take care of the equipment and or willing to make sure that you're paying your representative to have a good service contract. Remember, this is not a big old hole in the ground with 10,000 gallons of petroleum. This is a lot of moving parts. You want to make sure that you're properly taking care of your compressors, your filters, that you're doing all the basic maintenance to make sure that you're getting the most out of your equipment. Beyond that, it's really best to look at individual specifics of your application.
Wonderful, Steve. We do have some other questions here, and I don't want to hold too many folks on the line here. We will follow up with every question that has been submitted. There will be a survey sent out after this session, and there's an opportunity then to get questions answered in person. So I apologize, but we have gone to now 70 minutes here. The webinar itself will be available online at a later date, probably 2 to 3 weeks. We do tend to send these out, have them just edited up a little bit, cleaned up, and then presented online for your access consistently. There's one last question here from Mark we'll touch on, and then we'll sign off. Are there any advances or breakthroughs visible on the horizon beyond spark ignition that promises dramatic improvements?
I think there's a number of things, and it's not just beyond spark ignition. Spark ignition gives us a wonderful ability to go with stoichiometric combustion, which gives us an ability to go with a very simple exhaust after treatment system that doesn't require DPFs and SCR technology. And that's really where a lot of the increased cost of the diesel technology has come. Where I think we're going to see some real improvements, to be honest with you, is taking our current spark-ignited large engine technology, and I'll go first with heavy duty. Light duty is a little different here. But in the heavy duty sector, the engines that we have right now are still basically using a throttle body injection system, and we can take technology that's out there right now that's already available and start applying direct port, not direct injection, but port injection technology that gives us an ability to get much better control, better efficiencies, better horsepower and torque out of our current engines, so that not only will we grow in the number of engines and displacement sizes, but I think we can see good improvements to the current displacement sizes we have. Our current 13-liter is running 400 horsepower and 1450-foot torque. If you see companies take that technology and start applying port injection technology, individual controls, there's lots of things that can be done with the current technology to squeeze additional efficiency out of that same bore size in terms of engine. When it comes to the light duty sector, of course, we see the Europeans moving forward with gasoline vehicles, and now here as well with direct injection technology. We still have some problems to solve there with natural gas being applied to that kind of application because of some of the properties of the gas. One, it's going to be burning hot. We're talking about also the fact that it's dry. So we're creating a slightly different combustion environment inside that cylinder. And what we have seen in some of the new biofuel vehicles that are coming out, like from GM this year, is they'll have a port injection system when it's running on gas, but it'll be a direct injection system when it's running on gasoline. And they'll have the ability to use gasoline intermittently during the combustion cycle with natural gas, not as really a reason to provide power or input of BTUs, but to use the gasoline as a way to cool down the injectors that are right there in that hot environment and to try to lubricate and cool it down. So there's some innovative things going on that I think our industry is going to continue to invest in, which is to get all the latest technology and apply it to what we currently have on the road. In the heavy-duty sector, we've got a fair amount of room there, I think, to move a good 5, 10, 15%, maybe 15% in terms of overall performance out of the same bore size.
Wonderful. Thanks so much, Steve. Thank you for everyone and your questions. We've got contact up here. Again, you can go to the website, request specific information. Again, to those groups of engineers who are sitting around a table, do send us all of your contact information so we can send out a confirmation email and you can get your education credits for this. Last quick reminder on the upcoming webinars. You can sign up on the website and join us again. One final thank you to Steve Yborra, our presenter. A fantastic session, Steve. To Dave Van Laar, our PEng advisor, who's here in the room with us. And, of course, to all of you who've joined. Thank you very much, and we'll talk to you in a month.